finally the end of section 4.3, and this is just like the circle problems. Like in the last set of problems where we wound up completing the square, which was kind of parallel to the circle problems we did in chapter 2, this is exactly the same as that. So for each of these problems, I'm given a picture of a parabola, and I'm asked to write the equation of the parabola. Pretty easy to do. The first thing I'm going to do is use the generic standard form of a parabola equation that I introduced kind of lamely in the last video, and I'm going to take the vertex and put this in to the formula. The vertex in this problem is the point 2, I guess that's -5. My writing kind of went over the, my graph went over the vertex a little bit. What I'm going to do is I'm going to plug in 2 for h and -5 for x. This is going to give me f of x, which I can think of as y, which it might actually help to think of as y, equals a times x minus 2 squared plus -5. And this plus or minus can always be changed to just a plain ordinary negative. So that parabola that I have graphed on the screen, that's basically what the equation has to look like. It has a vertex of 2, -5. Basically, to get the vertex, so if I was going to make a table, I would put a +2 in the middle of my table, and that +2 would be the x-coordinate of the vertex. And if I started going up and down, well, I guess I did it backwards here, but it doesn't matter. My calculator would give me the y of -5. The vertex for this would be 2, -5, regardless of what number I put in front of the parabola. But there are lots of parabolas that go through the point 2, -5. There's super wide ones, there's super narrow ones. I need to find the parabola that passes through the point -113, and not so terribly hard to find the parabola that passes through that point. If I just take the y-coordinate of the point that's not the vertex, plug it into the y or the function side of the equation if I leave it in function form, change the x-coordinate of the point that's given that's not the vertex, take the y, plug it in on the left-hand side, take the x-coordinate of the point that's not the vertex, plug it in on the right-hand side, and just do the algebra to solve for a. And that's going to be finished up my answer. This is almost my answer, or this is almost my answer. I just need to get the a proper. And let me do the math here. This is going to be a times -3 squared minus 5 on the right side equals 13 on the left side. I'm going to do two things at once just to save some time. I'm going to add 5 to both sides, and I'm going to do the exponent because I'm running short on real estate here. When I add 5 to both sides, I cancel the 5's out on the left side. On the right side, I get 18 on the left side. -3 squared is +9. So this gives me 9a equals 18. I divide by 2, I divide by 2, I get 9 equals to a. The equation of this parabola that has a vertex of 2, -5 that passes through the point -113, there's a million ways to write it. If I use function notation, I could write the function notation f of x. The 2 would precede the parentheses. I would get an x minus 2 inside the parentheses because the x-coordinate of the vertex is 2. And then either a plus -5, which looks odd to me, or a -5 after. And nothing more than that. I don't need to graph this. It's already graphed. No tables of values, no increasing, no decreasing, no maximums and minimums. Just find the equation and stop. 27 and 28 are flipped over, so the number in front of the parentheses has to be negative. In 28, the vertex is the point -2, 6, and my additional point is the point 0, negative 6. So the shell of my equation I'm going to get by taking these 4 bits of information and slowly plug them into my equation. I'm going to change my f of x to y. It makes the algebra easier for me, and that's always permissible. I'm going to leave the a on the right hand side, but I'm not going to leave the h. I'm going to change the h to the x coordinate of the vertex, which is negative 2. And I'm not going to leave the k. I'm going to change the k to the y coordinate of the vertex. Technically, this is the appropriate parentheses for standard form of a parabola. Standard form of a parabola has a minus inside the parentheses. I'm going to change that double negative to a plus real quickly. And when I write my answer, I don't mind with parabolas having a plus in a parentheses, even though it's not perfectly standard form, but I can deal with that because it's not particularly hard to figure out what the vertex is, which is kind of what standard form is good for if the negative sign is replaced with a plus. So worked with the vertex. Now I'm going to work with the additional point. The additional point has an x coordinate of 0. It has a y coordinate of negative 6. I'm going to take the y coordinate and plug it in on the left hand side of my equation. Even if I had function notation, I'd take the whole left side of the equation and change it to that notation. I change it to negative 6. And inside my parentheses, I'm going to plug a 0. Let me do the algebra again fast. So I'm going to minus 6 from both sides and get negative 12 on the right side. And then the parentheses becomes 2 squared because it's 0 plus 2 squared, and I canceled out the 6's. So this is going to give me negative 12 equals 4a. And then I'll divide by 4, and get negative 3 equals to a. So I'm going to, into either this form of the answer or that form of the answer, change the a to negative 3 and call that done. It's good that I got a negative because the parabola is upside down and I have to have a negative out front. So the equation of 28, I can write f of x equals negative 3, and then I could have the double minus in the parentheses. Then it's in a form where the x coordinate of the vertex is the number after the minus sign. In this case, it's negative 2. If I don't put the double minus in a parentheses, it's kind of what I'm used to doing. Then I'd have to change the sign to get the x coordinate of the vertex. From both of these, the y coordinate of the vertex is positive 6, and they both tell me the x coordinate of the vertex is negative 2. Here, it's in perfectly standard form. The number after the minus sign is the x coordinate of the vertex. Here, it's not in standard form, but if I just change the sign of that number, I get the x coordinate of the vertex. Just a couple more of these to do. Let's go ahead and do 29 together. Why don't you pause the video and try 29 so you can check it out to see how you're doing. Just in case it's not visible, the vertex is the point negative 2, 6 for 29, and the extra point is 2, 14. When I look at 29, it looks a little bit wider than the last graphs. It could be that the number in front of the parentheses is a fraction. It's definitely going to be positive because this thing isn't upside down. So as I start, I'm going to use the generic equation for a parabola, and I'm going to change the left side to y. It just makes my life easier until I get to the answer. And inside the parentheses, I'm going to change the h to a negative 2. After the parentheses, I'm going to change the k to a 6. I'm going to do a couple things on the next step. I'm going to make the double negative a positive. I'm going to change the x to 2 and the y to 14. So this is going to give me 14, which is the y coordinate of the extra point, equals a times change the x to 2, change the double negative to positive, and do my bit of algebra. I'm going to minus 6 from both sides and get 8. And this is going to be a times 4 squared, which is 16a. Divide by 16, divide by 16. 8 over 16 reduces to 1/2. This is good because it opens up. The a has to be positive. It looks a little bit wider, so it had to be a fraction between 0 and 1 for the a. Now for an answer, I'm going to get back to the function notation. I'm going to put a 1/2 in front of my parentheses that will have a squared out front and a plus 6 afterwards. And then the proper way to write this would be x minus negative 2 squared. The x coordinate of the vertex is a number in standard form after the minus. In this case, it's negative 2. But when I deal with parabolas, I don't have any issues at all about having a plus in front of the parentheses, which isn't really standard form. I just have to commit to knowing I have to change the sign. And when I did my tables, I didn't have anything in standard form. I just took this and changed its sign and started marching by 1 to fill up my y's. And I always would get my vertex right there. And even without my calculator, I know the y coordinate of the vertex is 6. One more problem. I'll pause the video and try 31. I'll do it so you can see. So in 31, the vertex is the point negative 2, positive 3. The extra point, oh, I can't barely read. It looks like 2 negative, I can't really tell. Oh, it is 2 negative 1. It's marked there. I just couldn't read it. The font here isn't good enough for me. That extra point is 2 negative 1. So start off, use the generic form. I'm going to use it with a y without the f of x. It's going to make my life a little bit easier. And in place of the h, I'm going to plug negative 2. Yeah, and I already put the 3 in. I was supposed to put a k there, but I already knew it was going to be a 3. Now I'm going to move down, plug negative 1 in for y, leave the a alone, plug again 2 in for x, change the double negative to a plus, leave my plus 3, minus 3 from both sides. That will give me minus 4. And then on the right side, this is going to be a times 4 squared. So this is going to give me minus 4 equals 16a. Divide by 16, divide by 16. And reduce this. And this reduces to negative 1/4 equals a. When I go to write my answer for 31, I have to have a negative 1/4 in front of my parentheses. And then in terms of inside my parentheses, quite honestly, I would prefer the plus. But you're more than welcome to change a plus to a double negative. If you have the double negative, then the number after the negative sign is the x coordinate of the vertex. If you change the double negative to a positive, you have to change the sign to get the x coordinate of the vertex. The y coordinate of the vertex, you keep the sign. So that's everything from 4.3. We just have one section of new material left and then the practice test.